Once again, welcome everyone. I have been teaching, as you know, structural engineering for a long time. And before that, I also used to be a visiting lecturer in one of the architectural schools. And what I noticed about architecture at that time was that the architectural students are taught history of architecture for almost 5 years of their duration. And there's always a subject called history of architecture. And they learn from what has been done before. They know about what great architectural projects have been done, who has done them, and the concept behind them. As engineers and structural engineers, we are taught on how to do things, but not enough on why to do it this way and why not another way, and what has been done before that and why did they do that. And also, we are not familiar with the people who actually created a lot of the iconic buildings and bridges and structures that we see around that. So this talk today is not about iconic structures, but rather the structural system that they introduced, and after that they become common for other buildings. So I will just pick a few. These are not the best or the tallest or the biggest, but they are unique in the way that they were started, and also the stories of the engineers who developed them. Let me start with this image. I think many of you might have seen this one. This is actually an image of two engineers at that time, and a third, their assistant. And this is Sir Benjamin Baker and Sir John Fowler with Naveed as one of their assistants. And they were trying to convince the people in Scotland to build a bridge against a river where a previous bridge had fallen down recently, and public did not have a lot of confidence on engineers at that time. So they came up with this idea, but to demonstrate how it works, they actually created this human bridge concept, in which you can see very clearly that there is a load, which is Mr. Watanabe here, and then there is a tension force which is carrying through the arms of the two gentlemen, and is going to anchor into the foundation. And then finally, the compressive forces flowing through the struts below their arms, and then going on down to the chairs and down to the ground. So as you can see here, from the load to the vertical pillars and to the anchors, to the foundation, the whole force flow is very simple. It's just tension and compression forces flowing through. So once they demonstrated this one, behind is the picture of the model of the bridge they want to propose. It was kind of accepted by the public, and that was the result of their design. It's a beautiful bridge still over there, and this is called the Forth Bridge, and was built in 1890 in Scotland. And I visited that bridge, in a year and a half ago, and I took this picture, and I was just amazed at the scale of the bridge constructed at that time, and the clarity of the cantilever, and the central span in between that. So it's a marvel of engineering, considering that was done a long time ago. But the idea that we are trying to sort of learn from here is that the force flow was so simple that they could demonstrate it to a novice, to a layman, simply by creating a kind of a mock-up. And that's how it should be. That's how it is. Things are very simple. And we will see how they are moving forward. So if you go back in history, we have seen a lot of structures built prehistoric, before engineering, architecture, and anything. And most of them relied on intuition and also relied on mass, primarily to just create a structure very massive, and it would last. When one that did not last, we don't know about them, they became ruins. And the one that are here were just very massive masterpieces. And here are some of the examples. And what you can see from here is the scale of the structure on the left-hand side, which is huge, as we know, hundreds of meters tall, but it's all pure mass. There is nothing there, no forces, just a mass sitting like a rock sitting on the ground. And on the right are the arches, and that was the first time people started to use masonry to follow the force through the mass and again to the ground. And then you can see in the middle the beam structures, or the structures which were not based on mass and not based on compression but on bending, and they just weren't that big and they didn't even survive. And also from the basic understanding that the force can flow through a compression arch, as long as the force is within the structure, it would not cause any bending, so it would be stable. So that was the understanding developed long time ago. So it was either through an arch or through a rope. So these were the two basic instruments or basic concept that the people have to build structures. But then came bending, and Galileo, as you might have seen this image a lot, first time discovered or tried to solve the problem of a cantilever with a bending, which was neither in compression nor in tension directly, but because of bending, it produced shear and also it produced indirect tension and compression stresses. So this was the first time that they tried to figure out what would happen if we didn't have an arch or we didn't have a cable. And this understanding started a complete sort of revolution in engineering. And then we have people like Galileo who first observed that in 1600s, followed by Robert Hooke, as we all know, his famous equation equating force and displacement. And then after that, Isaac Newton, who motion and displacement and acceleration physics plus the moving body, and then from Thomas Young, who started to work on the material side. So now we start to have some mathematics and physics behind the working of these structures once that was observed. And then it started a whole development with the foundation of engineering and material and reason, because now we have equations and math to work, not just pure intuition from the people. So we have stone to iron to steel to concrete and now composites. So this is how we are now moving in this area.